We've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. And really thinking of the factory like a product. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10.
So this is what we're trying to do here is say, okay, how do we, with one factory, achieve what maybe 5 or even 10 factories would normally be required to achieve? Tesla will be absolutely head and shoulders above anyone else in manufacturing. That is our goal.
Hey, I'm Steven and this is Solving the Money Problem. If you're new, welcome. If you're not, welcome back. If you're Ford, General Motors, Nissan, Volkswagen, Hyundai, Honda, Nissan, any automotive manufacturer that isn't called Tesla, make sure you're sitting down for this. All right, are you ready? You are fucked. Well, the world is finally waking up to the fact that Tesla has an unassailable lead in battery cell technology, in software, and in autonomy. They seem to be completely asleep to the most obvious fact that Elon Musk himself has pointed out repeatedly in the past. Tesla's true long-term competitive advantage is manufacturing. So if you're a Tesla shareholder, or an engineering nerd, or even better, both, join me as we take a look at what's possible as Tesla continues to improve their manufacturing techniques over time. But first, hey guys, if you live in the US and you'd like to help out the channel and get up to 4 free stocks, check out the link in the description to WeBull. If you open a new account, you'll get 2 free stocks between $2.50 and $250 each just for opening an account. And if you deposit $100, you'll get a further 2 free stocks valued between $8 and $1,600 each. That is an obnoxiously good return on your investment. I mean, really, deposit $100 and you'll end up with, at minimum, $21 worth of stocks, a 21% ROI on your money. And if you're in Australia, the UK, or New Zealand, you can get a free stock with stake also using the link in the description. Let's get back to it. We'll start in 2016 with some comments from Elon Musk at Tesla's annual meeting.
We've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. And really thinking of the factory like a product. Not sort of a hodgepodge of things that are bought, where the machines are kind of bought from a catalog. But actually, just like we do with the car, we don't try to create a car by ordering a bunch of things off a catalog. We design the car the way it should be, and then we make either we or with working with suppliers make all of those individual components. And there's almost nothing in a Model S that's in any other car. And I think the same approach is the right approach to take when building the machine maker, the factory. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10.
Let's just take a moment for the implications of that to sink in. We already know how far ahead Tesla are with the technology in their vehicles. Nothing comes close to their vehicles in terms of range, performance, acceleration, over-the-air updates, so the software prowess, not just the actual hardware. I could keep going on. We know how far ahead of everyone Tesla is. There's literally no competition at this point in time. Given how far ahead Tesla is technologically with the vehicles themselves, if Elon's right, and there's at least 10 times as much room for improvement in the machine that builds the machine, the factory itself, the implications of this are absolutely stunning.
And I've really come to appreciate that, over the last 2-3 months in particular, when I've sort of just been on the production floor all the time and sort of seeing things, running production personally at a detail level. I don't even have a desk or an office anymore. I'm just basically standing on the production floor and occasionally meeting in a conference room. And it's like, wow. I do my favorite thing, which is apply physics first principles. It's like the best tool possible. And it's like, wow, when you think of a production facility on a fundamental level, for a given size of factory, the output is going to be volume times density times velocity. So then let's sort of look at our factory and say, okay, what is the density of useful to non-useful volume? It's crazy low. It's like 2 or 3%. If you look at volumetrically, not just on a planar level, but volumetrically, it's literally 2 or 3%. When you say car to non-car ratio, volumetric ratio, Like, wow, okay, that seems like there's a lot of room for improvement. And then you say, like, velocity. What is a reasonable expectation for the exit velocity of vehicles from the factory? And at first you may think that, say, some of these advanced car factories around the world are very good at making cars, and they may make a car every 25 seconds. And that sounds fast. But actually, if you say, well, the length of the car plus some buffer space is approximately 5 meters, and so it's taking 25 seconds to move 5 meters. Okay, that's 0.2 meters per second. Basically, you're not much faster than a tortoise at that point. So it's like, wow, that really doesn't seem fast. Slow walk would be approximately, or slow to medium walk would be 1 meter per second. And a fast walk would be 1.5 meters per second. And the best car factories in the world are doing 0.2. Like, seems like you should be able to have cars exit at least walking speed. This doesn't seem so crazy. And then the density improvement, like there may be as much as an order of magnitude improvement in density possible as well, going from maybe 2 or 3% to 20 or 30% of the volumetric density being optimal. And like you also think of it like the design of a modern system on a chip or a computer. And you say, if you look at, say, the complexity of the board, and you see how close together the line traces are, and how focused things are on clock speed and data transfer from RAM to, say, a solid-state disk or the internal CPU cache, it's like, wow, there's crazy potential for improvement here. I think at least an order of magnitude potential for improvement on production.
Now, we could go deep down the engineering rabbit hole here. If you don't understand a whole lot about integrated circuits, computer chip designs, get on Google, do some homework, learn a little bit more, and then you'll be able to understand what Elon's talking about here. But irrespective of that, just approach this from a more general point of view. Have you ever heard another CEO of any company talking like this? Period. Doesn't happen. Does that mean that any other CEOs are thinking like this? Unlikely. This means that Tesla are uniquely positioned to pursue the opportunity in improving manufacturing techniques. No one else is even thinking this is possible, so they're not even trying. We can see this in the automotive industry. There's been very little innovation in manufacturing techniques over the last 100 years. I know that sounds like an exaggeration, but the truth is it's not.
And so with less, like significantly less engineering effort, we can make dramatic improvements to the machine that makes the machine. I think like probably a lot of people will not believe us about this, but I'm absolutely confident that this can be accomplished.
So just to point out the obvious, although I don't think it's as obvious as it should be to a lot of people, Elon Musk is smarter than you. Considerably so, in fact. And Elon Musk also understands the universe from the atoms up. He has a physics understanding of the way things are and how they work. Elon Musk is able to use his big brain and apply his physics thinking, first principles reasoning, to understand what is theoretically possible in the future. If Elon Musk has a high level of confidence something is possible, he hasn't just pulled this out of his ass. He's thought his way through this and can see a reasonably clear path to get there. It may not be an easy path, but there is a path to get there. So, when Elon says he believes it's possible for an order of magnitude improvement in manufacturing techniques, and he has a high level of confidence in this is the point when, if you're a competing company, you start shitting bricks. Unless, of course, you're too naive, oblivious, or just plain dumb to realize this is a likely outcome, in which case you just continue about your merry way, gently progressing the way you always have, not attempting to innovate too much, and being completely and totally unaware that you're currently on board the Titanic, headed for an iceberg called getting your ass kicked by Tesla.
Yeah, there are opportunities we're finding all over the place, and as you start to, shift some of the design resources that have been, improving motor technology and power electronics or batteries, and are working so hard to try and find 0.1% of efficiency gain or performance gain on those different systems, and when they start to go and look at the factory, they say, oh my gosh, this is crazy. We can find, as you were saying, easily 10% or 20, in some cases hundreds of percent efficiency gain that were sort of unheard of in terms of what you could do in the design world. So the impact there is pretty phenomenal and quite close at hand.
Yeah, so we're basically going to design design a factory like you design an advanced computer. And in fact, I think use engineers that are used to doing that and have them work on this. And I found that like once you sort of explain this to a first-rate engineer, the light bulb goes on. They're like, wow. As JV was saying, like they spend huge amounts of effort trying to get a fraction of a percent of improvement on the product itself. But actually, that same amount of effort will yield an order of magnitude greater result if you focus on building the machine that builds the machine. And it's just that a lot of engineers don't realize that this is possible. They think that there's like a wall. They're basically operating according to these invisible walls. And so we just need to, we're in the process of just going through and explaining those walls don't exist. And I think it's going to be pretty amazing.
I really like the way that Elon explained this. It's as if there's invisible walls, but when examined closely with the right tools, the right lens, the right perspective, first principles and physics thinking, suddenly it turns out that the walls don't exist after all. So now we're going to fast forward 4 years to 2020 for some updated thoughts around Tesla's manufacturing techniques, the machine that builds the machine, potential for improvement. We'll look at some real life examples of these new learnings being implemented in Tesla's new factories, including Shanghai and Fremont. And we'll also look at some of the financial implications this could have on Tesla the business, and pretty likely Tesla stock over the long term.
Yeah, you can sort of think about like the sort of the fundamental physics of a factory or something. Like, I think it's actually quite a lot like the rocket equation, where you've got basically in the rocket equation you've got your exhaust velocity and then the log of the start to end masses. So it's basically saying, how fast are things going and what percentage of the factory volume is doing useful work. And conveyance does not count as useful work. So
only the value-added steps.
I just want to pause here because this is an extremely important point. Drew here trying to explain the difference between doing useful work and useless work. Conveyance, aka moving shit around, not useful, it's not productive, it doesn't add any value in the process. So the less movement, the less distance objects and items need to travel, and the more often they can be moving and having something done to them as well, a useful value-added step while they're being moved from point A to point B, the better. So now let's look at a little example of this in motion in Tesla's new battery cell production lines. This is a great example of useful value-added conveyance. Not only are these battery cells moving through the production line, but a useful step is taking place. In this case, the caps are being screwed on. And yes, I've slowed this footage down quite dramatically so you guys can see what's actually happening.
Yeah, if you break the factory down into cubic meter sections and say, or smaller, it could be like 1 liter sections, and say, is a majority of this volume doing useful work? You would be astounded at how bad most factories are. They're like maybe 2 or 3%, including our factory in Fremont.
First of all, 2 to 3%, absolutely abysmal. Huge room for improvement. Second of all, did you notice Elon is always very careful with his word selection? He said, including our factory at Fremont. The implication there, the Shanghai factory, more efficient. Cato Road battery cell factory, are more efficient. And regarding Elon's question there, is the majority of this volume doing useful work? Let's now look at another example from their new cell production lines to understand what he's getting at here. This is a stunning example of a vast improvement in volumetric efficiency. Just imagine throwing a three-dimensional cube over the top of this space, thinking about how much of it is doing useful work. Battery cells aren't just moving in a long, linear, horizontal, planar direction. They're actually going up, diagonally, sideways, moving through the space in a much more efficient way. The throughput of this versus something that would be long and linear, not even comparable.
So I think it is possible to get to at least 10 times that volumetric efficiency. So more like 30% ish, maybe more, and be 10x better, which means the factory can be 10 times smaller. And then the other thing is, how fast are things going through the factory? It's like speed and density. The faster you go, like if a factory that's moving at say twice the speed of another factory is equivalent to 2 factories basically. And the company that will be successful is the company that with 1 factory can accomplish what other companies take 2 or 3 or 4 factories to do. So this is what we're trying to do here is say, okay, how do we with 1 factory achieve what maybe 5 or even 10 factories would normally be required to achieve?
And the vertical integration with the machine design teams at Groman and Hybar and others allows us to really accomplish that, because we don't have all these edge conditions between one piece of equipment and another. We can design the entire machine to be one machine and remove all of these unnecessary steps.
Yeah, I mean, basically Tesla is aiming to be the best at manufacturing of any company on Earth. This is the thing that's actually most important in the long run. I think, just from a company standpoint and from basically achieving sustainability as fast as possible, but I think also for long-term competitiveness, eventually every car company will have long-range electric cars. Eventually every company will have autonomy. I think, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing. That is our goal.
Just imagine Tesla gets to the point where they can produce in 1/10 the factory footprint the same number of vehicles or other products as a competitor, or Tesla can make a factory the same size and produce 10 times as much. This is something I think most investors are completely overlooking. Tesla's existing factories have the potential in the future, by improvements in volumetric density, to double, triple, quadruple, quintuple, 10x their output over time. And as Tesla continues to delete parts and processes, shout out to the gigantic Giga press, which will feature in a moment, they'll continue to improve the efficiency even more. There's two components here: the volumetric density and efficiency of the factory itself, moving things around, etc., and how many pieces, parts, processes actually are required to produce the vehicle. If you can increase the volumetric density and at the same time delete parts and processes, this is a recipe for absolute dominance. This is what Elon's getting at. And now we're going to take a look at a great example of this, Tesla's gigantic Giga press. We're now going to look at a drone flyover of Tesla's gigantic Giga press in action at the Fremont factory. Let's have a look. We can see here already, stacked 4 high, a bunch of the gigantic Giga castings already. This machine is cranking these things out at a staggering rate. And I want you guys and girls to understand, this process, this gigantic Giga press, which is creating these Giga castings, this has literally eliminated literally hundreds of parts and processes. These parts no longer need to be stamped, moved about the factory, stored, welded, glued, affixed, attached, nothing of the sort. This is an incredible example of Tesla's quantum leap forward in manufacturing speed and efficiency. And this is just one example. I don't think people truly understand the implications. Imagine Tesla pumping out most of the frame of a vehicle in a matter of minutes rather than hours. This is incredible. Just imagine this same level of innovation applied to every other step of the process. Tesla is not finished. They're just getting started. I hope you guys are starting to get a sense for the stunning implications of Tesla's focus on the machine that builds the machine, the factories themselves. We can infer, based on Tesla's rate of progress and a ground-up first principles physics understanding of what's possible, that Tesla truly has the ability to dramatically reduce the costs of manufacturing products, therefore increasing their margins and or driving costs down, and speed up the rate at which they can produce vehicles. Now, guys, remember, long term, Tesla is aiming to produce 20 plus million electric vehicles per year. The only limiting factor at this point in time is 1, cell capacity, battery cell capacity, which they're solving with their new production lines, and 2, their ability to actually produce the vehicles. The faster these factories move, the more efficient they are, the less factories that need to be built, the less equipment that's required to actually build the end products, the faster Tesla's going to get to that ridiculous volume of 20 plus million EVs per year. The race is on. Yet it appears to be Usain Bolt versus a bunch of toddlers who 1, can't walk, and 2, don't actually know they're in a race. Probably won't end well. Tesla's leaps and bounds forward in manufacturing techniques and efficiency are what's enabling their $25,000 Model 2 to launch within just a couple of years. Tesla's Model 2, as it's tentatively being referred to now, will absolutely crush the internal combustion engine vehicle and destroy most legacy automotive manufacturers. No, this isn't hyperbole. I'm not exaggerating. I'm telling you guys what's going to happen. When this vehicle comes to market, superior product, better performance, lower total cost of ownership, and a cheaper entry price than an internal combustion engine vehicle with similar specs, it is game over. And guys, I don't know if you realize this or not, spoiler alert, just in case you don't want to ruin the ending here. The Model 2, Tesla's $25,000 electric vehicle, that's not going to be the final generation Tesla. There will be another generation subsequent to that, even cheaper, even more manufacturing efficiencies. At that point in time, if there's anyone left even competing with Tesla in terms of producing vehicles, you just throw your hands up in the air and just say, fuck it, I'm done, I give up. We quit. So I hope you guys have found this video insightful. Nowhere near enough people are discussing Tesla's manufacturing advantages or the trajectory or their rate of progress. If you look into the future and realize what Tesla's doing today and where they're heading, the implications are truly stunning. So now I want to pose a question to you guys. Let me know in the comments below. when do you think this next generation Tesla will be available? Just to give you guys a quick recap of Tesla's product history, Generation 1 was the Roadster, Generation 2 the Model S and X, Generation 3 the aptly named Model 3 and Y, and Generation 4 Tesla's $25,000 vehicle. What about Generation 5? When will Tesla release their Gen 5 vehicle, and what will be the starting price? I'm Stephen Mark Ryan, this is Solving the Money Problem, and I love you all. And don't forget, if you live in the US and you'd like to help out the channel and get up to 4 free stocks, check out the link in the description to WeBull. If you open a new account, you'll get 2 free stocks between $2.50 and $250 each just for opening an account. And if you deposit $100, you'll get a further 2 free stocks valued between $8 and $1,600 each. And if you're in Australia, the UK or New Zealand, you can get a free stock with stake also using the link in the description. Thanks so much for watching. Let me know your thoughts in the comments below. And of course, if you have any ideas for future videos, let me know. I read all your comments. PS, if you're still watching, you're awesome. If you'd like early access, exclusive videos, regular Q&As, our private Discord server and more, consider supporting the channel at patreon.com/solvingthemoneyproblem so I can keep creating content for you guys. There's a link in the description. You can now also become a member of the channel for some exclusive perks. To learn more, click the join button next to subscribe. And don't forget to check out our merch store. Either way, the best form of support is you being here and watching, so thanks again.